Hi, welcome you again to this EPJ Pathshala. Now, this is Dr. Vishwanath Datta from Documentation Research and Training Center, Indian Statistical Institute, Bangalore Center. I am an assistant professor there. Now, continuing to the previous module, that is advanced course in information storage and retrieval 1, that is on, it was on natural language processing. Now, in this module number 12, that is on advanced course in information storage and retrieval 2, and it is on the semantic web. Now, there is a actually the this is a kind of continuation to the previous chapter, as you can see from that 1 and 2. So, in the previous module number 11, we discussed about the usefulness of natural language processing techniques or natural language processing in information storage and retrieval. Now, in this context, now in this particular module 12, we will see the semantic technologies and techniques, how the semantic webs, the idea of semantic web and the semantic technologies and the various semantic techniques so far can be applied to improve the users experience, users search experience in terms of document retrieval, and not only just probably I won't say it's just about document retrieval, it can also be used for the knowledge or specific information retrieval also. Okay. Now, the main objective of this module is basically to understand the what is this idea of semantic web and what are the various semantic web, also I would refer it as semantic techniques and technologies exist today as per the recommendations even W3C, and then also we will see the kind of combinations, or you see that how natural language processing and the semantic web can be placed together, and you can just try to discuss that, or in fact we will discuss on this module that how this one can be benefited from the others. So, as a conclusion to this, we will discuss about also that the relationship between the NLP techniques and the semantic web technologies and how they can be used together to improve the overall information, to improve the search and retrieval of document or any other sort of information. The main objective of this module is basically to understand the what is this idea of semantic web and what are the various semantic web, also I would refer it as semantic techniques and technologies exist today as per the recommendations even W3C, and then also we will see the kind of combinations, or you see that how natural language processing and the semantic web can be placed together, and you can just try to discuss that, or in fact we will discuss on this module that how this one can be benefited from the others. Before we actually start discussing about this semantic web techniques, technologies and so forth, let us just have a look about this our current web, that what we in our day-to-day life we are using, that is, and I am sure that most of you are familiar with Google, and possibly most of you probably using even that Google search engine. Now, you just have a look into this particular slide, what basically you have. So, we have just tried to search with these keywords like rice, leaf, dried, color, gets brown. So, my problem was actually to find out some kind of solution, because where I found that my rice leaves are getting dried and that color becoming brown. Now, if we search this one, this is what we got the search results, where you can see that 376,000 hits I got. Now, the main problem as a human being, I doubt really whether I can really go through of all those 376,000 hits. And even I don't know, I never even attempted to calculate the time that I may need to spend to really go through of all those documents. This is one. Now, the second thing is that, as you can see from this figure, that what you have in this picture, you have basically lot of hits, and it is encircled. You see that we received some of the results which has nothing to do even with the rice, except the first one is the rice, but again it's not that really relevant. But again you look that second one, it's related to some kind of favorite Ukrainian cookery recipes of my family, which is completely different. Even you look onto the third one, fish preparations. So what basically it refers to? It refers to that web we are using, they are mostly the syntactic kind of web. I mean, in a sense that it's just kind of, it goes by matching the keywords that we put in the search box. It just try to match it, and accordingly it retrieves that documents. So this gives us a hint that there is a lot of improvement is needed in terms of semantic. Because why it is happening? Because we are talking about its syntactic web. Because what? Because it's not able to interpret the word like what I mean by rice or leaf or dried, color, gets, it's not able to really interpret or understand the meaning, or even it's not able to even understand the context, in which context I am looking. Maybe it is true that first one is that it has that brown color and all, it is matching by the word, but again that context is completely a different one. And this is so for the same thing in the following links also. Now from the previous slide, as we have discussed, we have discussed that how this in Google and we search and what is our experience. Just to summarize that, what we can say that this the problem with the current web, now current web means the web we are now seeing in our everyday life, or we are using the various kind of search engines like Google or Yahoo kind of search engines, that what are the major problems as we can infer from the previous slide, that it's basically that now the recall is very high and the precision is very low. This is one of the problems among others. Second thing is that the current web actually is more like a presentation oriented rather than really in terms of this kind of the semantic processing. What we can say that in the sense means this this whatever, if you look onto this web as we discussed in the previous slide, this all what we do, all that HTML tags or whatever we use, it's mainly for the display purpose. Like what we do, we say for some content we want to highlight, so either we make them as bold or we use some font color to highlight it, or say for example we want some italics, or we want something to be in a very bigger font face and all. So these are all basically display oriented, where human being, as a human being, I have to consume that information. Every human being has to read it, understand it, interpret it and consume that information. It is not that system can actually understand my requirements and accordingly it can return me the relevant documents or the relevant information that I might be looking for. The other issue is that like results are also highly sensitive to vocabulary. This is another problem which even we discussed in the natural language processing, where we are talking about the problem of information retrieval systems. The same problem continues here also, that basically these are highly vocabulary sensitive in a sense that whatever the terms you provide into the search box, it will match with that index, the document index, and accordingly wherever that keywords occur in the document, those documents will come, that documents only will be retrieved. Now the thing is that it's not necessary that you might be looking just by terms, because the problem is that the system really doesn't understand the meaning. If you are searching by, say for example bank, system really doesn't know which bank you are looking for, whether it is a financial institution or you are talking about a bank of a river. Now so wherever that match is found, system will retrieve those information. So it is highly sensitive to vocabulary rather than the meaning of that terminology. The another problem is that also like the results are mostly the single web pages. What happens, this whatever results, say for example we want to for example we want to visit a doctor today. Now what we have to do, for each piece of information we have to really consult the different pages, and then we have to gather the complete information from multiple pages, and then only we can satisfy our information need. For instance, as I said, the doctor, I want to visit a doctor, I am looking for a specialist, and I may have a different kind of other criteria like that. I may not be able to pay more than certain amount of fees. I may not be able to travel to like a far away from my place, or maybe it can be also that I may not be able to really go to the time, like say for example morning 9 to 5 because that's my office time, only after the office I can visit. So so many informations we need, and what happens that when we need to collect this information as a human being or manually, we have to go each of those different pages, collect that information, gather them, compile them, and then only we can prepare a list. After that only we can decide that which doctor to visit. And this is the same problem even if you consider in some another example like e-learning. If we consider some student wants to go for a higher study, he or she has to actually go through different profiles of the multiple universities, their fee structure, their the character, I mean the kind of criteria for the selection, whether you have to write exam, when you have to apply, and so many things are, so many parameters you have to really go through one by one. And most of the cases what you will find that those things are basically placed or kept in different pages. Now because of that, system is not basically able to consume that information, so system cannot really process that information even though it is there. As a human being, you have to go there, you have to scan through all those pages, you have to understand, you have to interpret, then only you can do. Now the situation that we are thinking whether we can have a situation that where on behalf of us there might be some agent who can understand our requirement. It is like that going to an travel agent. You are asking the travel agent, you give your all the requirements, and then he finds the relevant, that say for airplane or something, and then he suggests you, okay, you can go for this particular airplane. So this is similar like that in a web context. The idea or the effort is basically just to create an agent so that that agent can take our requirements, then it goes through the different documents or the information whatever is available on the web, and mostly the structured data, or I mean mainly we are talking in terms of the structured data. So it can go through that various piece of data and it can process it, and then it can match the actual requirements with matching that criteria and all the kind of constraints we impose on our search results. By matching those things, by filtering out, system can actually provide us that exact solution. Now we talk about the semantic web, because this is what our main topic is of this module. Now what is semantic web? I mean this term was, and the idea of semantic web coined by this, I mean this idea basically created by this Tim Berners-Lee. It is his brainchild only, and as usual that he was also the inventor of this World Wide Web. Now according to him, this is an extension of the current web, because we cannot leave out this current web. So we are not talking about something new. So according to him, it's a web of data that can be processed directly and indirectly by machines. So here the emphasis is given on the machines. It's not that just human being, because at present what we do, the current web is basically for the human being to process it, understand it, interpret it, use it, I mean consume it. Whereas in semantic web, the emphasis is on given also that machine and human being both together cooperate, both should be able to consume and both should be able to process and consume rather. So according to him, it is a vision of next generation web which enables web applications to automatically collect web documents from diverse sources, integrate and process information, and interoperate with other applications in order to execute sophisticated tasks for humans. Expectations and demands. So what we basically expect from the semantic web are so-called the techniques or the technologies. The expectations or the demands are that system must be able to automatically find or discover an appropriate service. System must be able to determine automatically how to invoke or execute the service. It must be able to select and combine a number of web services to complete a certain objective. Like the example we gave, like say for example, you are opting to find a you want to find a course in abroad or in some university, you want to apply for a higher study and you are looking for that university. So here the question is that the different web service, the different agents will be working on behalf of you, and finally it will try to come out with a solution near to your objectives. Now system must be able to verify and monitor the service properties while in operation. Now the motivation for semantic web are manifold, but here we basically discuss mainly in terms of two, that is automation in processing web-based information, and the other one is that interoperability of web-based information. What we mean by automation in processing web-based information is basically it would be nice if computers can do more on the web. Solution is make information on the web more machine friendly, as the example we gave in case of the doctor and e-learning. Interoperability of web-based information is It's basically combining information from multiple sources. So web services like discovery, composition, invocation and interpretation, interoperation, in a sense that so machine to machine communication should be possible. So one system should be able to communicate with others, but to communicate they should speak in a same way. They should probably use the same language to express their ideas so that we can understand. It is similar like that if I speak in English and if you speak in Hindi and we do not understand both because I speak English but I don't understand Hindi, you speak Hindi but you don't understand English, the problem is that we will not be able to make a successful communication. To have the successful communication, it's a kind of in context of computations we talked about this interoperability. This happens or this is possible only when we talk using the same language and possibly using the same logic. We should be able to express the thing in a same manner so that each of us or each of the software programs can understand each other. In this slide, as we can say that this is called the semantic web technology stack. This is also quite popular. I mean, people call it as semantic web layer cakes. As you can say that, or you can see that this is basically a kind of layers of technologies that where it starts from the existing, like say for Unicode, URI, because this already we are using, even this whatever we are calling syntactic web, still we are using these technologies. Then we have like XML namespace, schema, then we have RDF schema, ontology, vocabulary, logic, proof, trust. These are some of the things like starting from this RDF and RDFS ontology and above. These are mainly introduced in terms of the semantic web technologies, and that is the reason we are saying that, as we said that in the definition of semantic web, that semantic web is just an extension of the present web. It is not a new, and that's why you can see here we are still using the basic technologies which are already there in the current technologies like Unicode, URI, XML and so forth. This is another way of placing that same technology stack, but the technology wise they are more or same. This is just a kind of refinement, but the previous slide that which consists of that technology stack actually was proposed by Tim Berners-Lee and their colleagues, which actually was the first one. This is the most refined one and it came recently. So this is again this in the previous slide we have seen that the layers, the stack, or we say that semantic web layer cake. So before going to those technologies, each of them actually we will discuss, but before going to that I just would like to mention that there is actually this layer works in two different ways. One is that upward compatibility and the one is that basically the downward compatibility. The upward actually it's not compatibility, it is more called that upward partial understanding, or So what basically does mean, or what does it mean basically, that when we go from the bottom towards the up, is basically it is expected that the agent we place into that web, it has to understand all the stacks on the down, but it can, or it should be able to at least understand the partially of the higher end technology which is just above that layer. It is that understanding is that, like say for example from the previous stack, say for RDF and RDFS layer you had. Now if that agent or the software program whatever you have, that basically is based upon that RDF and RDFS, it should be able to actually even understand or process in some extent that the layer above that is, say for example OWL. Only thing is that what it can do, it can just disregard some of the elements which are basically specialized within that OWL, but those are basically of the RDF and RDFS that should be still interpreted or should be processed by the system. On the other side, that which we are talking about, the downward compatibility, it is basically that software program should support, or the software agent or program whatever you write, it should be able to understand each of them, because the idea why we are talking about these two kind of compatibility, one is that the downward compatibility, and the other one is that upward partial compatibility. It is because that, see, if you want to really have the semantic web, that idea, or you want to place it, it's not necessary all the layers that just we have seen in the previous slide. It's not that every technologies, every such kind of techniques has to be in place. You can stop it at anywhere depending upon your situation. You may prefer to stop it, say for example in the RDF-RDFS layer, you just create your, data set just up to RDF-RDFS technologies use and create it. Then you think that no, your purpose goes little beyond that. What you can do, you basically consider, okay, we take this owl because that is your requirement. So you go to one more up. Again, if you think that no, you need to apply the logic, you need to apply the truth, trust, all the layers you want, you can go. So what happens, it starts from the bottom. So as you move, anywhere you can stop depending upon your requirements. Subset of the SGML, that is standard generalized markup language, and it lets everyone, the idea of XML is basically it allows you to create your own tags. Like in HTML, you are not able to create your own tags. Whatever was defined or is defined by the semantic web HTML specification document, you are bound to use those tags only. Like if it is bold B, you have to use B, you can't use possibly P, because if you use P, it will be considered as a paragraph. Or if you want to use some break, you have to use BR, you can't make something else. So here, but XML actually gives you that the kind of provision to create your own tags, whatever information you want to describe. This is one, again, it can be further related with the HTML, that in HTML, as we said, that this is mainly for the presentation purpose. What basically does it mean, that what you could do, you could emphasize your documents, the terms you want to emphasize. That's why we are saying that it is more display oriented rather than information representation oriented. Whereas XML actually will allow you, using this XML technologies, actually you can describe your content. You can, like say for example, if there is a author in HTML, you had to write just B just to make it bold, that author name. But in XML, you can write author tag and then you can add the author name and close that author. So this way actually you basically tag the information rather than just to make it presentable. So now there are many salient features of XML are like it is extensible, machine accessible, separates content from formatting, and also it's a meta language for markup. However, there are many issues are also there, as it is that nothing is not, it's perfect, nothing is ideal. So there are also some issues or limitations we have with this XML. Like say for example, XML does not ensure standard vocabulary and subject to interpretation. So that means it's really whether you use author or writer, there is no standard, you use whatever you want. Also it has there are many other major problems. Just to mention one more is that basically it's a domain specific markup language. There are many markup languages have already occurred, like say MathML, CML and so forth. But the problem is that this leads to a problem of non-standardization, because everybody will come up with its own domain specific markup language, and then again that communication, that interoperability becomes again a question. So to solve that problem, we go to the next technologies, because that next technology that is called RDF is RDF and RDF schema, which will try to overcome these limitations of XML. We talk about this is resource description framework, RDF. This is quite a popular data model. Okay, it's basically a data model designed for the semantic web. So the idea is that this any knowledge you want to, any piece of knowledge you want to express, you have to express it or you have to represent it using the standard formula, that is that RDF resource description framework. It's basically based on the idea of identifying things using web identifiers. The main technology behind RDF is that identifies that every objects, every resource, rather we say that in semantic web we mainly use that resource rather than object. So RDF is basically a domain and application independent and can be used for describing, for instance, any like your shopping items, information about your web pages, electronic library items, content for search engines and so forth. The goal is to make information available for the applications to process rather than only display to the human beings. That is what we understood as a one kind of limitations of this present HTML based web. So the fundamental concepts in RDF exist. There are four concepts, fundamental concepts. They are called resource, property, valuable and statement. What is resource? Resource is basically can be considered as an object or a thing we want to talk about or you want to describe, and that's the reason I was talking that anything you talk in semantic web, they are basically a kind of resource or a thing that you can describe, you can communicate about it. For example, here we have so many objects, like you have that journal, say journal of knowledge organization, which is an object and you want to describe it. Or say for example, you have an article within that from knowledge organization to knowledge representation and you want to talk about it, so you can describe it again. And say for example person, that Phostogynculia, which is a person, and you want to describe or you want to talk about it, and each of them has the web presence, each of them basically has the URI. So URI for all the resources, URI is must, it must have that URI. That's the core idea of RDF is. RDF properties are basically it's also a kind of special resources. It's basically a kind of relationships between the two resources. For example, as you can see from this slide, that you have that one article called from knowledge organization to knowledge representation, which has web URI, which is a resource, and I want to say that it is created by Phostogynculia. So he is the author, creator. So here that creator actually is the RDF property, or is a kind of link or the relation between the article from knowledge organization to knowledge representation and the person or the author who created, that is Phostogynculia value. Now it is the value for the property of a resource, because we talked about the resource, that is that resource, then we talked about the property. Now we are talking about that what is the value of it. It's like that attributes, that properties are these properties are kind of attributes or the relationships between two resources. So here value also you can consider is basically is the value for the property of a resource. For example, in the following figure we can have, like say for example from KO to KR. It is published in Journal of Knowledge Organization. So here the value is basically Journal of Knowledge Organization, and this value is for that property published in. Similarly, from knowledge organization to knowledge representation, this article is written by, so the creator is the property and the value is Phostogynculia. So here the resource also, the value also is a kind of resource. However, the resource, that values, the values of that property can be of two types. It can be the literals, and the other one is that URI reference. Literal means when you don't want to describe that value as a, or don't want to consider that value as a further resource which you can further describe. That's why, like say for example my height is just an height say 5 feet 6 inch, that's a value, that's all, because I cannot further, I don't want to talk about or don't want to define that what is 5.6 inch, what does it mean, and any kind of descriptions you don't want to make. But when it comes to that who, I mean say for example I have a friend, so here myself and another person is there, and these two persons, I mean me and that my friend, can be connected with a property called friend. Now here that person can be further described, or say for example in the previous slide we saw that from knowledge organization to knowledge representation, that article is a resource, and for that property was that one property was creator, and we had that value Phostogynculia is a person which can be further described. So that's why we can have two types of values, either that is literals, that means it is not a further any resource, so you don't really need any URI for it, but you can have also a value having the URI reference so that it can be further described again. Now data types, RDF basically has no built-in set of data types of its own. It uses the XML schema data types like XSD string, XSD boolean, XSD time. Here XSD basically refers to the XML the data type. RDF provides no mechanism for defining new data types. That is the one of the issues, that in RDF you cannot really create any new data types, or you cannot define any new data types like you could do in XML. In the schema file you could actually create your own data types. You could extend the existing XML suggested or XML schema data types, you could further refine and extend, but in RDF it is not possible. However, but the use of any externally defined data types, data typing scheme is allowed in RDF documents. So now RDF is basically, as we said, that it's a kind of data model. That means a piece of knowledge like Ram is a boy, how it should be encoded into the system. You say that Ram here is a resource, is basically a predicate, and boy is a property, the value property that is a that value is boy. So you could actually make it like subject, predicate, object, and this way you could model your piece of information, or that from knowledge organization to knowledge representation, that creator is Phostogynculia. So here from knowledge organization to knowledge representation is basically a subject or the resource. Then you had this creator is a predicate, and then you had the Phostogynculia which is an object. But in RDF schema, this is basically a kind of schema which allows you to define your classes, because when I write that kind of string like from knowledge organization to knowledge representation, creator, Faustozunculia, we don't have actually any vocabulary because RDF doesn't provide any vocabulary except certain few very basic vocabularies. But you need vocabulary to express things, like in natural language also we cannot say something without knowing the words. So here also RDF schema, the idea is also to create or to define your own words into there and build the schema. So that's why you can say that you just can specify in RDF schema classes, properties, class hierarchies, property hierarchies, class instances and so forth. The important thing is that RDF schema itself does not provide a vocabulary of application specific classes. It provides a framework, more specifically a set of constructor to do so. That means it gives you the basic foundation on which, on top of that, you can further extend it and create your own vocabulary. So this slide actually shows you the kind of this, you can see that there is a boundary between RDF and RDFS. You had that RDF, that is a statement like networking is taught by David John. This is what the data, that actual data you had to represent. But now to represent that data, you can have a schema which is actually kind of in RDFS, using that RDFS foundations or the techniques, you can actually create that vocabulary to describe this kind of data, that like here one example we have networking is taught by David John. What you are getting here, as you can see from that RDFS, that here that networking we are saying that what it is, because you don't know, but machine will not understand what is networking. As a human being, you may be able to process it because you know networking we teach in the classroom environment or in academic environment. So it's a kind of course, right? Or say for the example this semantic web. Now I am teaching, so semantic web tutor Dr. Vishwanath Datta. Now here the semantic web is a course, but that you know how system will know what it is. So you have to tell explicitly that this is actually type of courses, and that courses can be connected with further its hierarchy. Okay. Similarly, say for example creator, what is creator, from where it is coming. So all these things you have to define. Even say for example Vishwanath Datta, who is that? Is it a tree, or it is a book, it's an article, or it's a human being? Or in this context, in this academic environment, he is basically a kind of faculty member. So you have to really have a schema where you define, like here say for example David John is a type of professor. So he is basically a professor, and that professor is a subclass of academic staff member, and that academic staff member is a staff member. So you have complete. So if I tomorrow ask who is David John, you can tell me, oh, he is basically a staff member, or you can further specifically you can say that, oh, he is a professor. Okay, that you can say. But without that, you also may not be able to say that who is David John. You may say that he is an actor, he is a tutor, or he is, he is a professor, or he is kind of a laborer. Anything you can talk about it, unless you have that schema, unless you define what exactly it is. And in system, if you want that system to be work, logically and semantically, we need to provide this kind of information in the system, so that it can understand each of the piece of words and all, and then you can infer accordingly, or it can semantically retrieve something. So what we cannot do in the RDFS, but again this also technology also is not free from any limitations. It has also some of the issues, like say for example it is too weak in describing resources with sufficient details, like there is no cardinal restrictions, like I cannot say that a course is taught by at least one professor or persons have exactly two parents. We cannot say no transitive inverse or symmetrical properties, like cannot say that is part of a transitive property like that. Or we cannot say that graduate and PhD students are two disjoint classes. Similarly, there are many other limitations, or we can say that we cannot express certain kind of semantics within this RDFS also. As from the previous layer stack, if you remember that, there we had that one layer called ontology. So what is ontology now? This ontology actually, it started in, it was a part of this metaphysics, where metaphysics was the part of the philosophy. So what basically it's about philosophically, it's called that what entities exist or can said to be exist. That is what that philosophers wanted to find. What basically, it's a basically kind of study of a being or thing, what exists in this world. Okay, that is what the main idea of it. But in computer science, an ontology is a model for describing the world that consists of a set of types, properties and relationship types. There are more refined and more popular definition also is available on ontology, that is called formal explicit specification of a shared conceptualization given by Gruber in 1993. And there are many such kind of interpretations about ontologies are there, which you can go through it by the slides, I mean, as you can see from here and also from the document. Now, why ontologies? Now, ontologies is to help in structuring complex definitions and arrive at shared understanding. So, here the important things to consider are that what elements are needed or allowed in a model definition, what knowledge of an object system is required or essential or relevant to solve a problem using models, or what knowledge or expertise on modeling is required for a good modeling practice. The another thing is that also the communication between people, between computers or systems, and between people and computer. The why ontologies, because it has many applications like make domain assumptions explicit, then ordering and structuring of knowledge, analysis of knowledge, and so forth. There are many other reasons that for which we can say that why ontology is required. So, ontology consists of, now this is quite, when we talk about that ontology, we should also know that what it consists of. It's basically consists of the individuals, the instances, the objects like me, like this, say for example this PowerPoint presentation, like say for example your that module you are reading now, or maybe you, the table or chair you are using, and all these sort of objects, they are basically the individuals, that's what we say, that instances or objects, that basic or ground level objects. Classes are basically sets, collections, concepts, classes in programming, types of object or kinds of things. It's like that, say for example, like I can say that student is a class, because like you, another friend of you, all if you are student, basically all if you can be considered as that you are all student, but each of you have the name, or if you, all of you are basically the individuals of that class student. So, here that individuals, that in the previous bullet what we said, that individuals, these are actually you and all your friends, whereas class is basically that student, that which you are actually bringing all the students together, like you and all your friends coming together, and you are forming a group or class called student. Attributes are basically the properties or the kind of characteristics of these different classes. Like say for example the student will have these characteristics, say for example in which course, I mean which course they are studying, what is their probably the roll number, what are the scores they made, and all sort of characteristics we can derive for the student class, and all including your name and also forth, which are more common. Then relations, this is basically a ways in which class and individuals can be related to one another. So it's like say for example I can say that like student also is a person, okay. So here basically like you, an individual is actually you are a student, say for example of a particular course, let's say for example semantic web. So what exactly we are getting that? We are saying that student 1, okay, and you and that course which is also a class under course, you will have NLP as a course, then semantic web as another course which is an individual. So here the student 1 you can be connected with the semantic web because you are taking that class course. So that means we can relate it, you and this course semantic web, that you are a student of this particular course. Now we can have also in ontology like restrictions, like which can be called as formally stated descriptions of what must be true in order for some assertions to be accepted as input, and as well as we can have the rules and axioms as part of the ontology. Now we talk about the logic and ontology language, which also was one of the layer in that layer stack was the logic. Why logic? It's basically in representing knowledge. Logic plays an important role. Logic enhances the ontology language further. It helps to establish the consistency and correctness of data sets and to infer conclusions that are not explicitly stated but are required by or consistent with a known set of data. So some of the important features of logic are like language, formal semantics, reasoning, inferred knowledge explanation. You can go through all of this, but I will just discuss about this reasoning. Say for example, in an automated reasoners can reduce or infer conclusions from the given knowledge, thus making implicit knowledge into explicit. For example, you have in that knowledge base only stated like X is a cat is a mammal, and a mammal gives birth to young ones. You have only these 3 statements or 3 facts in your knowledge base. But if you have these semantic technologies in place, if you have used the semantic techniques and technologies, then the system, if you have that inferencing system or the reasoner, it can reason or infer that saying that X gives birth to young ones, even though this one was not explicitly stated. This that X gives birth to young ones, it was very implicit, because from those three facts you can as a human being can process, but system also can equally process, because we apply some logic, we use that logic language to express those three facts like X is a cat is a mammal and so forth, so that system can automatically reason and tell you that okay, X gives birth to young ones, and that is the power of this semantic system. So we talk about the description logics now, because as we said in the previous slide about the logic, so there are many logic languages are already available. They are called as a kind of knowledge representation logics also, formalisms. So here we talk about the description logic, but you have the first order logic and all. Description logic is basically a kind of subset of first order logic. So it's are basically formal logics with well defined semantics. Semantics of DL is defined through model theoretic semantics, which formulate the relationships between the language syntax and the models of a domain. And it's, as I said, that it's basically closely related to first order logic, because as I said that it's a kind of subset of first order logic. And in designing DL, the emphasis is given on key reasoning problem decidability and the provision of sound and complete reasoning algorithms. A key feature of DL is their ability to represent relationships beyond the EJ relationship that can hold between concepts. In DL, the important notions of domain are described by concept descriptions that are built from concepts, that is unary predicates, and roles are basically called the binary predicates. It's like that, say for example, you want to say that what is your height, that's basically, so height is an attribute or it's a predicate of you, and the value is basically so what basically, say for example, your name is student 1 for example. Now the unary predicate is here basically to say that you are basically an individual, okay, of the class called student. So here what it will happen, so it's basically it's called the unary predicates, because here the student is the class and you student 1 as an individual, whereas that roles, that is binary predicates, will be used of various concepts and roles construct, in the sense that it can be used for connecting two things, like as I was giving that example, like say for example your weight, okay, or height. So height is your characteristics. So here height is a kind of binary relations, or is a role or the binary predicate, which basically talks about the you student and the height, say for example 5 feet 6 inch. So that's why it's called binary, that means 2. So it has the relationships, or it builds the relationship between two things. It is also possible to state facts about the domain in the form of axioms which acts as constants on the interpretations in a DL knowledge base. This is basically a basic architecture of knowledge, DL system architecture. So where you can see the knowledge base, which you can remember that in our module number 11 we talked about also knowledge base. So here also we are talking about knowledge base. In semantic environment, basically we have knowledge base means we split into two, that is called T box and A box. The T box is called the terminological box and A box is basically assertional box. T box consists of all the terminologies that the ontology, the terminology or the classes, the properties, relations you use in your ontology, that will be kept as part of T box, whereas A box is basically all the instances and their values like you, your height, your weight, all this kind of value and these individuals will be kept as part of the A box. And then on top of it you can have this inference system and you can infer a new knowledge from this existing knowledge base. We talk about this another advanced knowledge representation language. This is quite popular nowadays and it is a recommendation of W3C, World Wide Web Consortium. This is basically is recommended by W3C because of semantic markup language for expressing, publishing and sharing ontologies on the web. OWL is developed as vocabulary extension of RDF and RDFS, because as I said that in RDFS also we cannot do many things like we discussed, like that say for example disjointness cannot be expressed, constants cannot be expressed in terms of like cardinality constants, like a person can have 2 hands, I cannot express using this RDFS language, we have to use some other language. That is what that OWL is, which actually tries to overcome some of the limitations of RDFS and allow you to express your knowledge more in a more expressive way, and you can actually express many things which were not possible in RDFS. OWL is based on the earlier language like OIL and DML plus OIL, and so there are in OWL there are two species of OWL we have, that is basically OWL species use the open world assumption. The open world assumption is that if a statement cannot be proven to be true, with current knowledge we cannot draw the conclusion that the statement is false. It is something like that, it doesn't pretend to know that everything. If he doesn't know anything, it says that I do not know, rather saying that it cannot happen. Whereas in the closed world assumption, which is contrary to open world assumption, where it says that if you don't know certain thing, you say that that is not true. Okay, it is false. You tend to like that, but the open world assumption is that you basically, if you don't know certain thing, you don't say that that is false, you just say that I do not know, maybe it is there or somebody might know already. Now owl language has three families, or we can say that three species of owl, that is called owl full, owl DL and owl light. For owl full actually is a bigger one, that is actually it uses all the owl language primitives. That means you can see that it's a very bigger set. It allows free mixing of owl with RDF schema, and it is fully upward compatible with RDFs both syntactically and syntactically. Owl DL is basically owl description logic. So this is basically a sub language of owl full. So that means you can understand this is not big as owl full is, but it is some kind of subset of the owl full. So it provides maximum expressivity while retaining computational completeness, that is all conclusions are grounded to be computable and decidable. It includes all owl language constructs with certain restrictions. It permits efficient reasoning support also, but only thing is that we lose full compatibility with RDF, because RDF is quite free, whereas in owl DL you can actually, there are a lot of restrictions or constants you can apply. Owl light, this is further sub language or subset of the owl DL. That means you can understand this is much more smaller set of vocabulary it consists of than the owl DL and owl full. So putting further restrictions limits owl DL to a subset of the owl language constructors. Owl light excludes many things like say enumerated classes, disjointness, semantics. So that means you cannot basically again express the disjointness like we had that problem in RDFS. In using RDFS we were unable to express that disjointness like say for example between graduate, say for student and tutor. That student and tutor you cannot be, I mean like I cannot be as a student and as a tutor at a time. So that means that student and tutor are two different groups and they are disjoint properly. This kind of semantics or this kind of knowledge we cannot express using in RDFS, and also using owl we cannot, owl light we cannot do it, but owl full and owl DL allows us to do that. There are many advantages of owl lighter because it is easy to grasp, easy to implement for tool builders, and provides a quick migration path for thesauri and other taxonomies, because as a library professionals we are using that classification schedules, thesaurus and all. This can be actually straightway migrated from thesauri to owl light, because this is quite, I mean the thesauri and owl light, that is more or less they are very nearer to each other. So we can easily migrate from thesauri to this one, but if we want to migrate the thesauri to owl DL, we have to do lot of manual works. Now these disadvantages, it's restricted expressivity. Now owl ontology elements, owl ontology consists of classes, properties, instances of classes and relationships between the instances. So we can map between the DL and owl ontology like that whatever we are known in, I mean whatever we are calling classes in owl, they are basically considered or known as concepts in description logic. Similarly, what we are calling properties in owl, they are basically the roles in description logic. Also the instances that we are calling in owl, they are basically termed as individuals in description logic. Trust layer, this is basically at the top of this layer, this is basically to build the trust over the kind of services you receive, because whatever you are receiving the services from this kind of web, you must have some kind of reliability on that, so that you can understand, okay, this is I can rely upon or I can trust upon that. So there is also a layer of the technology which can actually build that trustiness, or which can allow you to have a secure operation. So in conclusion, we can say that semantic web is, each layer in the semantic web layer cake is built on the layer below. Each layer is progressively more specialized and also tends to be more complex than the layers below it. The layers can be developed and made operational relatively independently. As I said at the beginning, you don't need to have the semantic web, you don't need all the layers to be placed in the system. Anywhere you can do, or independently also you can build them. So semantic web and natural, so this is the kind of last of this module. that here we talk about the relationship between semantic web and natural language processing. Here we try to say that how that NLP can help semantic web. So here we say that NLP can help semantic web in two phases. One is in terms of acquisition phase and also at the time of retrieval phase. By acquisition phase we mean at the time of building semantic web, and by retrieval phase we mean that at the time of accessing the semantic web. So application of NLP in semantic web. So some of the applications of NLP in semantic web can be applied to build knowledge bases, can be applied to construct ontology, can be used in ontology learning. So now we reach to that conclusion. So in conclusion, or to summarize this entire module 12, we can say that semantic web technologies or semantic web techniques and technologies can be applied to organize and to represent our information and knowledge, so that we can retrieve our information more meaningfully. Because if you keep your information within that Excel file or HTML text file and so forth, it's not going to be consumed or cannot be processed by the system. We need to express them using some semantic understandable or machine understandable languages like say RDF or RDFS OWL, so that the various software programs, that agents can actually reason or can infer some new knowledge from that. With this, I would like to say that due to some short of time we had to go very fast, I know. However, I would suggest you to go through this PowerPoint presentation which will be provided with this module 12. You read both of this presentation and the module, I am sure you will be able to understand and go much deeper of this idea of semantic web and the semantic techniques and technologies.